Hello, welcome back. This is Frank here. Welcome back to the channel. So in this video we're gonna discuss about additional mathematics past year paper, May June 2024, paper 11. Should I say paper 1, zone 1. As usual, the duration of the paper will be 2 hours, and the page 2 will be a formula test. Okay, let's without further ado, let's look at the first questions. On the axis, sketch. Okay, we are required to just draw some diagrams here. Sketch the graph of y is equal to negative 1 over 5 bracket x plus 2, 2x minus 1, and x plus 5. So we are required to state the intercepts, okay, with the axis. What do you call an intercepts? Intercepts are basically the points, the coordinates where the curve cuts the x or y axis. So in order to find where it cuts the x-axis, you should find when y is equal to 0. Okay, when y is equal to 0, you just have to replace this y with 0. So you'll end up with x plus 2, 2x minus 1, x plus 5 is equal to 0. Technically, you can just ignore this negative 1 over 5 because you can just pretty much move it over to the other side and it will still be 0. So you only have to focus on the roots here, the linear roots, and you'll end up with x is equal to negative 2, 2x. So this one should be fast. 2x minus 1 is equal to 0, and x equal to negative 5. You just move over the 1, so you end up with 1 over 2. Okay, so these are the coordinates that you have to take note of, and negative 5, 0. So plot this point, you have to indicate clearly in your diagram, okay, because the question stated there explicitly stating the intercepts, so you have to really state up in the coordinates, negative 1, 2, 3, 4, 5. So this is negative 5, 0, negative 2, 0, and then 1, so that is 1 over 2 and 0. Okay, half. Now what should you do next? You should find out when x is equal to 0. This is where the point will cut the y-axis. So y is equal to negative 1 over 5. 0 plus 2, that's going to be 2. Just replace all the x here with 0. So negative 1 and 5. So this one you can cancel out. Negative 2, 0, 2. Okay, so 1, 2. Now, okay, this is where things start to get a little bit tricky. So how are you going to know whether how your graph will look like? Because eventually this is not going to show how you're going to sketch a graph. So I have one tips here and one tricks. Normally when it's a positive polynomial, okay, it's a positive polynomial, you end up with a graph like this. So it's going from low to high when the x cube is positive. If the x cube is positive, you end up the graph going from low to high. But if it's the other way around, okay, if your cubic is negative, it's going from high to low. Okay, so please remember this pattern. So now you know how the graph should look like. Okay, in this diagram, the maximum or minimum points doesn't matter. So you don't really need to use dy dx. Okay, use the derivative to find the maximum or minimum points because you just have 3 marks here, so you don't have to work extra. Okay, so just ignore that one. Just sketch out the pattern. Okay, remember the maximum or minimum point doesn't matter. So draw out the shape and we can call it a day. Okay, so this is your graph, but don't forget to label. Negative 1, oopsie, negative 1 over 5, x plus 2, 2x minus 1, x plus 5. There we go, perfect. Okay, so this is what you're going to show. Next one. Hence, solve the inequality. So hence basically means that you have to use back the diagrams that you have drawn earlier. Okay. Solve the inequalities, negative 1 over 5. Okay, so if you really look carefully here, this is actually your equations here, right? It's the same thing. So you might as well just replace the entire thing here with the y. So technically the region that they want is y is greater than 0, but where is y is greater than 0? Okay, y is greater than 0 technically refers to this side. Okay, y is greater than 0. We have two regions here, so in case you don't know, y is greater than 0 is the part where it goes above the x-axis. So this is your x-axis. So y is equal to 0 refers to the part where everything is greater than 0. Okay, the other one, y is less than 0, will be below here. Okay, will be below here. So this region is y is less than 0. So take note of that. Now let's move here. Let's go back to the original questions. Stated that we want the region y is greater than 0. So where the one that I shaded in pink, okay, is the region where the graph exceeds y is greater than 0. So you have here, okay, this is where the graph the function exists, okay, where from this point you can see that this line is definitely going to this side. So at this region, in order for this function to exist, so x has to be less than or equal to -5, because going here onwards, right, it will be negative, x will be -6, -7, and so on, and so on. And this region here is a bit special because it's in between, okay, it's in between -2 and 1/2, right? So you have two regions where this graph, okay, it's at y is greater than 0, okay, we're greater than or equal to 0. Sorry, that's my bad, but technically it doesn't affect our answer. So -2 is less than x, and would be in between -2 and half, okay, and 1/2. So this is where the function exists. So please note that this is basically your answer. X is less than -5, and -2 less than x less than 1/2. All right. Okay, let's look at questions number 2. So we have 6x cubed. Okay. All right, let's look at questions number 2. So how are we going to solve this one? Okay, this is also a polynomial question. By the way, the polynomial p is such that px, okay, function of p, okay, is 6x cubed minus 35x squared plus 34x plus 45. Find px in the form 2x minus 5 qx plus r, where qx is a polynomial and r is a constant. Okay, so normally students fail to answer these questions because they don't know what does the r represents and what does q represents here. Okay, so this is actually, r is actually your remainder, while q is actually your quotients. Okay, there's a hint, you know, the q is actually your quotient. So what do we mean by that? Okay, so you have to use your long division to find out, right? 6x cubed minus 35x squared plus 34x plus 45. Okay, put the whole long chain of polynomial in there, and the 2x minus 5 is actually your divisor. Okay, divisor is the thing where you have to put outside here. So now whenever you do long divisions, okay, you technically would want to refer this number and this number. See how do you make them 0, because every time when you do long divisions, it's gonna start from minus, right? So 2x and 6x cubed. So what do you need to put on top of here in order to get 0? So from experience, right? So 3x squared multiplied by 2x, that's gonna give you 6x cubed as well. Okay, so 6x cubed minus 6x cubed, okay, that's gonna give you 0. So technically it matches our conditions. So don't forget to multiply, sorry about that, don't forget to multiply the 3x squared with the -5 here as well, and make sure you guys are careful with the sign. 3 multiplied by -5, that's gonna be -15x squared. Okay, so the first one will be 0. -35 plus 15, that's gonna be -20x squared. Bring down the 34. Okay, I hope I didn't copy it wrongly. Bring down the 34x, and then you start to do the same thing all over again. So put a minus, put a bracket here, and then pull it long. Alright, so 2x, what will give you minus 20? So just put 2, negative 10x, that I believe is going to give you minus 20x squared. And then with negative 10x with negative 5, that's going to be plus 50x. Simple and clean. So 0, 35 minus 50 is going to be minus 16x. Bring down to 45. Then 3x squared minus 10x. What is going to give us 16 here? Okay, last, do the same thing all over again. Put the minus 8. Okay, minus 8. So minus 8 times 2, that's going to be negative 16x plus 40. So 45 minus 40, okay, that's going to be 5. So at the end of the day, the quotients refer to this whole thing. Okay, this is your quotients. Okay, this is your remainder. Okay, everything is still the same, so you technically just follow the writing order, 2x minus 5. Okay, but write down your quotient, 3x squared minus 10x minus 8 plus 5. That will be your final answer. Alright, and that's basically it. Next one. Hence, write the expressions px minus 5 as a product of linear factors. So when you see the word linear factors, you know that the highest order, okay, highest order of power will only be equal to 1. Okay, higher order of power, x will be equal to 1. So technically we are referring to x to the power of 1 then. Okay, x to the power of 1. So this is the maximum that it can go. Okay, so px minus 5, technically they want to trick you, right? So you just have to write down what is your px there. So this is our new form of px. Okay, because it's mentioned hence meaning you have to use your answer at the previous sections in order to answer this. So new form of px, we have 2x minus 5, 3x squared minus 10x minus 8 plus 5 minus 5. So plus 5 minus 5 you can technically cancel out. So all you have is 2x minus 5, 3x squared minus 10x minus 8. And don't forget, this one you can actually separate it into this form. Okay, factorize it by using quadratic method. 3xx, then 4 plus 2. Okay, so you just have to represent your answer in that form, and this is basically how you earn the 2 marks here. And another questions that requires us to hence write down the solutions. So technically they wanted to trick you for this, but if you move the 5 to the other side, it will be px minus 5 equal to 0. Remember what is your px minus 5 is equal to 0? Yes, you have it on the top part, right? So all you need to do is to just replace this whole thing with 2x minus 5, 3x plus 2, x minus 4 equal to 0. So the whole 2x minus 5 will be 2x minus 5 equal to 0, or 3x plus 2 is equal to 0, or x minus 4 equal to 0. Okay, solve for x, then you'll have all this as your final answer. Right? Logarithm questions. Write 1 plus LG bracket x squared minus 1 minus 2 LG x minus 1, where x is greater than 1, as a single logarithm to base 10. So give your answer in simplest form. So you can't meaning you can't use your calculator for this. Alright? And there's one thing. Okay, in case those who don't know, LG is actually a short representation for log 10, log to base 10. Right? So technically this is okay, but since there's 1 here, so this question requires you to know some characteristic about special logarithm. So you know that log 10 or LG10 will always give you 1. Okay, so because they have the same, technically they have the same base, right? The index, when the index and the base are the same, they'll always give you 1. Now convert 1 into LG10 plus LG x squared minus 1 minus, okay, so in these situations you have to move the 2, use your power tool, use the power rule, sorry. By power rule you can basically move the coefficient freely back into the power, so LG x minus 1 square, right? And then step by step, focus, you can do it in order. You don't have to combine it all at once, you know, and you know that's gonna be tough, right? So do the first 2 terms. So LG10, okay, LG10 plus LG bracket x squared minus 1, you're gonna end up with, okay, it's a multiplications, right? So in case if you don't know about this, LGA plus LGB, in order to combine them, so it's not when it's plus, right? Logarithm is special, so you always have to follow the rules. LGA plus LGB, it's gonna give you LGAB, okay? And LGA minus LGB, that is gonna be A divided by B, so A over B. Alright, so we have to follow these conditions in order to combine our logarithm. Okay, so 10 multiplied by x squared minus 1. Alright, that's cool. Minus LG x minus 1 square. So again, we're gonna, since it's minus, so in order to combine them, we have to follow the second rules here. So that's gonna be divide x squared minus 1, okay, x minus 1 square, close it. So we have 10 x squared minus 1, x minus 1, x minus 1. Do you think this is the end? I don't think so, because we have x squared minus 1, okay, that fulfills the conditions a squared minus b squared, where a minus b and a, you can simplify it further, so don't lose mark there. Make sure you do the steps. 10 x minus 1 x plus 1, okay, and then you can see there are actually like terms that you can actually cancel out, so these are the common factors, cancel out, take them out. So you will have LG 10x plus 1 x minus 1 as your final answer, okay? And you'll also be rewarded 4 marks for your trouble. Solve the equations. 4 log base 5 bracket x plus 1 is equal to 9 log bracket x base bracket x plus 1 5. So simplify your answer in the form of a plus b search c. Okay, so they're gonna cause you trouble for not giving you the same base. So what you need to do, okay, the prerequisite, right, you have to know how to switch the base. So technically log base AB, in order to change the base something, the new base, log C, so the index where you have to put it on the numerator, and the base you have to put it at the denominator. Okay, so that's basically it. That's basically the rules in order to change base. Now for these questions, okay, technically I would like to change it to base 5, okay, in order to make it easier, so we don't have to deal with like algebra stuff. So log x plus 1, I'm gonna change this x plus 1 into log 5, so log 5, okay, wait, I have to rewrite it here so you guys can see. I'm converting this entire thing into base 5. So log x plus 1 5, all right, log x plus 1 5. So log, okay, log 5, the index has to be in 5, then log 5 bracket x plus 1. All right, so put it down. Okay, now for log 5 bracket x plus 1, 9 log 5 log 5 bracket x plus 1, close it. So this is what you will have, right? And then when the base and index is the same, you always end up with 1. So that's a rule for special logarithm as well. When the index and the base, they're the same, it's gonna give you 1. Okay, so write it down. 4 log 5x plus 1 is equal to 9. 1 log 5x plus 1. Alright, that's very clear. So the entire thing here, okay, you can, in order to remove this, remove the fractions, you don't like the fractions, you can actually move the entire thing over to the other side. So you will end up with log 5x plus 1, okay, square 9 times 1, 9. Okay, for these questions, you can't just be reminded that, okay, log a b square is not equal to bracket log ab square. Okay, with something like this, it means that the power of 2 technically belongs to the b, but this power of 2 here doesn't belong to b. It's just referring to that there's actually repeated log base a index b multiplying together. But for this one, you can use power rule because the 2 there, the power of 2 technically belongs to b. So please don't make this simple mistake that will cause you to lose marks. Okay, just move the 4 back to the questions. Back log 5 x plus 1. Okay, I'm gonna cover it up. 9 over 4. Okay, how are you going to solve this? Power of 2. Move to the other side, so you end up with 2 possible answers. Plus minus 3 over 2. Okay, because it's when you move over to the other side, you end up with 1 square roots, right? Square root will technically refers to like you have one positive and 1 negative here. Okay, go on. Log base 5x plus 1, 3 over 2, or log base 5x plus 1 minus 3 over 2. Okay, now you have to convert, okay, logarithmic form to exponential form. How are you gonna do that? So 5, just write them down. 5, okay, this 3 over 2 move over to the other side, while the x plus 1 move over to the other side here. So technically that's the answer. And just a quick note, 5 to the power of 3 over 2, you can actually rewrite them as 5, 1 over 2, 3. Alright? Or the other situations where you make it easier, 5 to the power of 3 and then 1 over 2 on the outside. So technically 5 to the power of 3 is 125, and 1 over 2 to the power of 1 over 2 is just the square root of 125. So that would be 25 times 5, so 5 third 5. That is the simplified version, right? 5 third 5, x plus 1. Therefore, x is equal to 5 third 5 minus 1. First answer. Second one. So again, we use the same method. 5 and then minus 3 over 2 equal to x plus 1. Alright, so 5 negative 3 over 2, that will be 1 over 5 over 5, right? So it's the same thing. Or if you're not sure, just press your calculator. I'm sure that's gonna show. It's 1 over 5 third 5. But then don't forget to rationalize it. 5 third 5, 5 third 5. You're gonna be 5 third 5. Okay, 25 times 5, that's gonna be 125. So you end up with 5 over 25 then. Okay. I'm sure you will lose mark for not rationalizing as well. So make sure you do that. Okay, so 5 over 25 minus 1. Okay, that's the second answer. So you have 2 answers here. So the questions on series and binomial theorem. The first 3 terms in ascending power, okay, these questions are quite popular. In the expansions of 3 plus px to the power of n, okay, they have given you the products. Okay, you are required to find n, p, and q. So how are you going to do this? 3 plus px to the power of n, that's going to be 2, 4, 3, plus 810x plus qx squared. So where do we start? Okay, given the first three terms, so you have to attempt to expand this one up to first three terms. So that will be 3 to the power of n plus, okay, the formula will be, okay, focus on the first digit here. What is this? The 3, and focus on the px. All right, and maximum power is n. Remember the NCR. Okay, n is the number of maximum powers, while r is the number of terms. So the r will always start from 0. So r is equal to 1 is here, n c1. Okay, put the 3 here, the first digit 3, and px, then followed by 1 here, px to the power of 1, and then n minus 1. Okay, the minus 1 actually referring to n minus r. Okay, so that's how technically you should be able to do it. Plus nc2 3 px, you should put this as a power of 2, and then n minus 2, and this will go on, so and so on and so on. Okay, so that's how basically you expand up using binomial theorem. Oh, what's this? My bad. All right, so 3 to the power of n. Okay, nc1. All right, how are you going to do binomial expansions here? Okay, do you have to? Okay, check first. You don't really need to, because if you expand nc1 up, right, without looking at the questions properly, because some candidate might be too excited, so they will attempt to put nc1, you know, some formula, n bracket r, so n minus r bracket and r factorial. So they'll attempt to do this. So in this situation, you don't have to. Okay, please do not attempt to do this, because it's gonna be like a waste of time. Okay, so 3 to the power of n, you look to compare it with the answers given. So it's equal to 243. Of course, we only need the first three terms. So 243 plus 810x plus qx squared. Okay, so we are comparing the first term with the first here. So how can you compare 3 to the power of n with 243? So 243 is actually 3 to the power of 8. Sorry, 3 to the power of 5. My bad. 3n. Okay, 3 to the power of 5. So it's obvious that your n is equal to 5. And after you obtain this n, you can basically just put back into whatever you have right here. You see? You have here, you have all the n. So just put it back in. And then you don't have to factorize, you don't have to like use the NCR formula to break them down. Right? So come back here. Let me check the mic settings first. Alright, it's good. So NC1, okay, that will be the new version will be 5 C1 3 5 minus 1 px 1 equal to, wait, hold on a second. So this whole thing will be equal to this. Will be equal to 810x. So 5c1, press your calculator, that's going to give you 5. 3 to the power of 4 px and 810x. Cancel. So 5, 3 to the power of 4, 405p, and then 810. P is 810 divided by 405. So guess what? We will have 2. That's our answer. So we have P. Okay, that makes things even easier. Now we have N and we have P. So all we are required to find is Q. Okay, so technically you have to compare the Q, the third term, with the third term, right? So that's reasonable. So 5c2. Okay, 5c2, that will be 3, 5 minus 2. Then since our p is 2x squared, so 5c2 is gonna be, let me punch the calculator real quick. 5c2 is gonna be 10 2x squared. Okay, so that is 27 4x squared. So 270 times 4, that's going to be 1080 x squared. So that is q. So do we need x squared? Oh, we don't need x squared because this is equal to qx squared, right? So that will cancel out the q, the x squared. So technically q will be just equal to 1080. There we go. Perfect. Okay. Find the term independent of y in the expansions of 2y minus 1 over 3y squared, bracket 6 to the power of 6. Give your answer in exact form. So independent of y means that your x, okay, or any variables y will be to the power of 0. So technically without the variables x or y. Okay, you have to find the term where it's free from x or from the variables. Okay, so no x or no y. That's basically what they're saying. Okay, you can try to expand. Okay, step by step. Open up the bracket using the binomial theorem. 2y to the power of 6 plus, and from here 6c1. Okay, but make sure you check the power carefully. Okay, you know this is to the power of 5 divided by, okay, square. So the outcome will be y to the power of 3, right? Since 5 minus 2, then there's gonna be 3. Okay, so it doesn't work. Continue. 6c2 2y minus 1 negative 1 over 3y squared. So square 6 minus 2, that's gonna be 4. So check the power. Okay, so here this term is gonna be y to the power of 4. The other one divided by, okay, minus, there's a 2 and 2 here, so 2 multiplied by 2, you're gonna get a 4. So 4 minus 4 is gonna be 0. Okay, because the maximum power of y to the power of 4, okay, divided by y to the power of 4, so you end up with y to the power of 0. Okay, technically it's just 1. So the third term will be the term to look at. So we'll take this term, 6c2 2 to the power of y, 16y to the power of 4. Okay, square 1 to the power of 9y to the power of 4. Okay, so now both have y to the power of 4. Just cancel them and just do normal math then. 6c2 multiplied by 16 divided by 9, that's gonna give us 80 over 3. There we go, that's our final answer. The diagram shows the graph of y is equal to a cos bx plus c for negative 360, alright, until positive 360. So they have given us the graph and we were required to find a cos bx plus c. Okay, so this is clearly a cos graph because the easiest thing to find in this graph is actually the amplitude, right? So know what you're looking at is very important. Y is equal to a cos bx plus c. So we are looking at the amplitude here first. So a is the amplitude. So how do you find the amplitude? Amplitude is just basically taking the maximum 1 and then the minimum minus 9, try to find the middle value. So 1, okay, you can just play around with this. 1 minus 9 and then divided by 2, where is it gonna land? So it's minus 4. So minus 4 is basically your equilibrium line, your stable line, okay, the starting line here. Okay, just take it. Now that is where, how about your amplitude then? Amplitude you just have to calculate 1, okay, 1, 2, 3, 4, 5. Okay, so make sure the distance from the equilibrium line, okay, you check that's the peak and then there's the trope. So 1, 2, 3, 4, 5. So make sure they are equal. The one that's going to the highest point and the lowest point, if they are equal, then that is your amplitude. So your A is equal to 5, right? 5 units. Now, the second thing that is easiest to find is your period. Period refers to the thing here. Okay, so what is the cycle? Okay, the cycle of the thing of the sorry, how should I say this? What is the angle needed to complete one cycle? Okay, so in this case we have to remember the formula for period. So this is very important. Period. Okay, for sine and cos curve, there's gonna be 2 pi over b, or 360 over b. Okay, so b is where you have to refer back to your graph. It's the period of the where you have to look back in your graph, okay, and then find out the b. So now, except for sine, right? Sine is 180, so this is the period for sine and cos curves. Okay, so looking into these questions, what is our period here? Okay, period of the graph is, so the complete cycle, okay, the easiest trick that I can give it to you guys is to look at what is the angle needed to complete one cycle. For a cos, right, in order to complete one cycle, just refer the distance from here to here, from one maximum peak or lowest point to the others. So this is negative 240, it's negative 240, and this is positive 240. So what is the angle? What's the angle in between? Okay, what's the total angle needed to complete one cycle? 240 minus 240, so that's gonna be 240 plus 240, that's gonna be 480, right? And that's good. Now come back to our questions. 480 will be our period. It's equal to 360 over b, and we are required to find a b, so just exchange the positions. So you're going to end up with 3 over 4. So b will be 3 over 4. Right? Now, since you already have a and b, so that's pretty much easy to find. Okay, the last one is easiest to find, so just write it down. 3 over 4x plus c. So how do we find c? You can either just let your x be equal to 0 or y equal to 0, right? So in this case, I'm gonna let when x equal to 0. Okay, when x equal to 0, where is your y? Okay, the y is clearly 1, right? So it cuts the y-axis at 1. So y is equal to 1. So 1, 5 cos 0 plus c. Okay, and you know that cos 0, okay, is 1. So technically it will be 1 equal to 5 plus c. Therefore, c will be equal to negative 4. Okay, the next one. The line y is equal to p is tangent to the curve. Y is equal to 3 minus 2 sine 6 theta. Write down the possible values of p. Okay, so 6 theta is actually a lot of period right there. Okay, it's tangent to the curve. Y is equal to 3 minus 2 sine 6. Write down the possible values of p. So if we want to draw it, right? Are they the same graph? No, they're not. Okay, just roughly a quick sketch. Okay, so this kind of question is probably it says possible values of p, right? So there are probably inequalities involving here. So x and y. Okay, so I'm just gonna quickly draw without really care about the how it looks like. So when y is equal to when my theta, so this is equal to theta, when theta equal to 0, let's see where does it go. So y is equal to 3, right? 3 is over here. Okay, and then the amplitude is minus 2. Okay, amplitude 3 minus 2. The maximum, wait, I want to see how the maximum point that it can go. So the maximum will be 3 minus 2. When this is negative, it will be maximum, it will be 5. Minimum, it will be 3 minus 2, that will be 1, right? So the highest point you can go is 5, minimum you can go is 1. So 3, 1, okay. I'm just quickly draw a sample. And period. Period is, the B is 6. Okay, B is 6. So you have to use the formula to find out what is the cycle. Okay, period is equal to 360 over 6. 360 over 6, that's gonna be 60. So one cycle will take 60 degrees to complete. Okay, 60, I'm just gonna write 60 here so I don't confuse myself. 60, and then this is 120. Now, y equal to p is a tangent to the curve. Okay, write down the possible values of p. So tangent you can have here and here, right? So there's two versions where you can just draw. Remember, tangent is the point where it touches the curve once. Okay, just draw it here. Oh my goodness. Okay, so you can have two regions. So what is the possible answer? So the maximum, remember the maximum point that we can have is actually 5, and the minimum is actually 1. So you have two tangents. Y is equal to 5 and y is equal to 1. Okay, one tangent is crossing the maximum highest point. One tangent is touching the lowest point. So that's basically the answer. Okay, y equal to 5 and y is equal to 1. Alright, let's proceed with question number 6. So let me make this bigger. Oh my goodness. Okay, find integral limit. Okay, where the lower limit is 2, upper limit is 4, 2 over 2x minus 3 over 3x minus 5 squared. Giving your answer in exact form. Okay, let me do this. How do you represent our answer in exact form? First, you can always do this, right? To make things easier, separate them and always bracket up your denominator. Dx minus, look at the sign in between, it's minus, right? 4, 2, 3, bracket up, 3x minus 5 square root of dx. Now what are you gonna do here? Okay, so remember, when the highest order is power of 1, so it's always, the formula is like this. So to integrate a bx, right? So that's gonna be ln. Sorry, wait. It's gonna be bracket a ln bx, and by chain rule, you're gonna be divided by b plus c. Okay, that's just the formula when you are dealing with this kind of integrations. So open up 2 ln 2x minus 3. And with chain rule of 2x minus 3, the differentiations of this is going to be 2, right? So please divide it by 2. Close it for 2 minus. Okay, so for this we need reciprocal. Move this one up. So there's going to be 3x minus 5 minus 2. Okay, open up the integrations. 3x minus 5 minus 2. And the chain rule of 3x minus 5 is going to be 3, right? So over 3, close it for 2. Okay, cancel out, cancel. You're going to be ln 2x minus 3 for 2 minus 3x minus 5 minus 2 for 2. So that will be ln 8 minus 3 minus ln 4 minus 3, open up the limits. Okay. Oh, okay. So I forgot to plus 1 here, so you have to actually do that. So minus 1, that's actually gonna be minus 1. Sorry about that. And now you can still put it into the limits. So 3, 4, minus 5, minus 1, and minus 3, 2 minus 5, minus 1, close it. So you end up with ln 5 minus ln 1, that's gonna be 0 anyway, minus 3 to the power of. So that's gonna be 1 over 7. Since it's to the power of -1, right? Just punch your calculator in this case, and you're gonna get like 1. Okay, so ln 5 minus 1 over 7 plus 1, so that will be okay, plus 6 over 7. So that's our final answer. Alright, that's how you solve this integral calculus questions in general. Okay, so 4 marks. Next one. Right, given that 2 plus cot theta is equal to 3x and sine theta is equal to set y, find y in terms of x. So this is just a normal substitutions, but since you have a cot there, what are you gonna do? Okay, so you can't replace something that is not there, right? So 2 plus cot theta is equal to 3x. What you can do here, okay, you know that cot. Okay, there's another identity for cot where you can always refer back to the formula. Okay, so cot, okay, is equal to cosec square A is equal to 1 plus cot square A. So this is especially useful. So let me show you guys how to use it. All right, cosec square x is equal to 1 plus cot square x. So what you're gonna do here, you're gonna move the -1 over, and then you have cot that is equal to cot x, right? But since we're dealing with theta here, so I think later on you might have to change it back. So cot x will be equivalent to cosec square x minus 1. Okay, so that is what you have to do later on. Now, since to make it simple, I'll just change everything back to theta so that you can easily relate this to later on, cosec minus 1. And then you know that cosec, okay, cosec is actually equivalent to 1 over sine theta. Okay, and then you know that sine theta is equal to sert y, so that cosec technically refers to 1 over sert y. So just substitute 1 over sert y inside. Okay, 1 over sert y square minus 1, that's gonna be 1 over y minus 1. So bracket it up, 1 minus y over y, that's gonna be my cot, right? So since your cot, you have the variable y inside, so it's ready to replace it. So the original equations, 2 plus cot theta is equal to 3x. This is the original equation, so I just have to replace the new identity for cot. Just replace it, 1 minus y over y is equal to 3x, and then we have to find y, making y as a subject, right? So move the 2 over to the other side, so 1 minus y, that is going to be 3x minus 2. Okay, square both sides in order to remove the square root, so you have 1 minus y over y, that is 3x minus 2. So I'm not gonna open up the bracket just yet, okay, because apparently there's still a lot of things to do here. So remove the fraction, 1 minus y is equal to y 3x minus 2 squared. Okay, I'm gonna move this one closer a bit to the left because I'm gonna group up the common factors together. So that's gonna be y plus y 3x minus 2 squared. So take out the common factor of y, that's gonna be 1 plus 3x minus 2 squared. And then just move the whole up down, y is equal to 1 over 1 plus 3x minus 2 squared. There we go. So that's how you express y in terms of x for these questions, right? Alright, question 8. Solve the equation for sine square to alpha minus pi over 3 is equal to 1. Alright, for this one, since you remember you have to rotate it in clockwise, okay, clockwise directions as well. So things might look simple here, but you actually have 5 marks, so the working might be a bit longer. Take the 4, move over to the other side, so it's going to be sine square 2 alpha minus pi over 3 1 over 4. So again, move the square over to the other side, it will become square root, or technically you just root both sides, you're gonna end up with square root 1 over 4 with a plus minus, and that means you have to do both. When sine is equal to 2 alpha minus pi over 3 that, with the positive 1 over 2, okay, that's gonna give us the first and second quadrant, while sine 2 alpha minus pi over 3 to minus pi over 2, that's gonna give us the third and fourth quadrant. So for the first and second quadrant, we would like to have the region here and here, right? So we'll be rotating here. Now, the basic angle for, let me make it bigger. Sorry, let me have to make it bigger. 2 alpha minus pi over 3. Okay, that will be sine inverse 1 over 2. So 2 alpha. So remember, you have to express your answer in terms of pi, so make sure set your calculator in radians. So move this one. Okay, so that will be the first. Next, we have to, since this is the first quadrant, so pi over 6, and the second quadrant will be pi minus pi over 6. So in general, we will have 5 pi over 6, right? So move the pi over 3 to the other side, so pi over 6 plus pi over 3. We have to do that again. So that's going to be pi over 2. 5 pi over 6 plus pi over 3. That's going to be 7 pi over 6. Alright? And divided by, but technically pi is equal to pi over 4, 7 pi over 12. But this is going to be rejected because the value of 7 pi over 12 is far greater than pi over 2. So that's why it's already out of the region, wanted regions. We're gonna remove that one. So now that this is just when we are rotating clockwise, so you just extend this a little bit further. Okay, and you can start to rotate anti-clockwise. Sorry, clockwise, because of the negative regions, right? So rotate clockwise. Okay, you're gonna have this and this. Okay, it's the first and the second quadrant, but with a negative. Okay, I'm just gonna add one more here. It's negative pi over 6 because we are rotating the other way around, and also negative pi minus negative pi over 6. So we'll end up with, I think it's the same, it's basically the same thing, but it's just negative, right? Negative pi plus pi over 6, it's gonna be, sorry, plus pi over 6. So that's gonna be minus 5 pi over 6. Okay, again, move the plus the pi over 3, plus pi over 3, that's gonna be pi over 6, and the other one, minus 5 pi over 6, plus pi over 3, that's gonna be minus pi over 2. Okay, so move the divided by 2, so we have 6, 12, and then minus pi over 4. Okay, so check minus pi over 4 is technically still within the region, so these three is actually the wanted answer, the answer that we wanted. But is that all? Of course not. We're gonna do the same for the third and fourth quadrant as well. So again, the basic is not gonna change. The basic 2 alpha minus pi over 3, it's gonna be pi over 6, right? Pi over 6. But this time around, we're gonna play with the third and the fourth quadrant, meaning the third and the fourth quadrant here. So rotate here and all the way here. So that's what we wanted. 2 alpha 2 alpha minus pi over 3. So there's a high chance, there's a high chance that it's getting rejected, but anyway, it's worth to try. 2 alpha minus pi over 3. So the third quadrant requires us to plus the pi, plus the base 6 pi over 6, 2 pi minus pi over 6. Okay, it's the third and the fourth quadrant. So 2 pi over 3. So this is going to be 7 pi over 6, and then this is going to be 11 pi over 6. Okay, do the same. So we're going to move the 2 pi over 3 to the other side. It's going to give us 7 pi over 6 plus pi over 3. So 3 pi over 2. Okay, 11 pi over 6. I think the 11 pi over 6 would not give us the answer that we want. Would not give us answer within the wanted regions. So it's far too big. So divided by 2, you're gonna be 3 pi over 4, and then 13 pi over 12. So this one clearly we have to reject. It's rejected. So 0.5 pi and 0. Hold on, what was that? 2 pi, 0.75 pi. So this is also the rejected answer. So we don't need the two of them here. Now we have to check, okay, negative regions, right? How about when we rotate it in the clockwise directions? So clockwise directions, where will it be? So technically it's the same, but this time we only have the basic that is negative. So I'm gonna put it here, just show it using the brighter color this time. So that is gonna be negative, okay, negative 7 pi over 6. Negative 7 pi over 6, and also negative 11 pi over 6. Okay, so this time see what are the answers that will be different. After we move the negative pi over 3, that's gonna be 6 plus 1 over 3 minus, minus 5 pi over 6. And I'm sure I can ignore the other one, but whatever. Let's just make sure it's there, so the working is completed. And it's 3 pi over 2. Okay, so everything divided by 2, you're gonna end up with minus 5 pi over 12. The other one is 3 pi over 4. Okay, again, the negative 0.75 is rejected, and we only have one answer that is within the regions, within the wanted region, that is minus 5 pi over 2. So, right, so the wanted answer of alpha, that will be minus 5 pi over 12, okay, minus pi over 4, pi over 12, pi over 12, and pi over 4. Okay, perfect. Solve the following simultaneous equations. So we have the one with exponential functions, okay, exponential involved, and the other one is just a normal, x squared y is equal to 256. So first, your task, okay, is to make sure that you can substitute, do proper simultaneous equations, but of course not with exponential around. X plus y multiplied by e. I prefer you guys would use a dot here because you guys will be writing a lot of x, so in case you don't get confused, dot actually represents multiplications as well, right? So by power rule, okay, you can just combine rules of indices. If the base is the same, of course, then you can basically just add up the power, right? X plus y plus 3x minus 2y is equal to 1. Okay, e, that will be 4x plus minus y is equal to 1. I don't think this question is difficult because 1, technically it means that, okay, can be anything to the power of 0, right? Remember, anything to the power of 0 will be 1. Since we are making comparison, okay, in this case, so you might as well just make e to the power of 0 so that you can link the 4x minus y is equal to 0. You want to make the connections, right? So therefore, y will also be 4x. That is your first equations. Now, you just have to sub the first equations into the second one. So x squared would be 4x is equal to 256. So 4x to the power of 3, 256, okay, divide by 4, make x as the subject, 256 divided by 4, that's gonna be 64. So x, okay, cube root of 64, what is that gonna give us? 4. Okay, 4 times 4 times 4 is going to be 64, so x is equal to 4. What about the y? So x squared y is equal to 256, so y 4 squared, 16y, 256, divided by 16, cancel out. Therefore, y is equal to 256 divided by 16, so y is equal to 16. Right? That is the answer. Okay, that's all you have to do in order to get these 5 marks. Very simple, right? Now, the second one, it requires us to solve the equations e 2x minus 1 minus 11 is equal to 6e 1 minus 2x, giving your answer in exact form. Okay, so we have to represent our answer in exact form. This is actually not difficult if you are able to see that. Okay, 10 e 2x minus 1 minus 11 6e. Okay, so in order to make sure this one will look like this, what you need to do, all you need to do is to just take out the negative, right? So I factorize out the negative, so it will look to it will become minus 1 plus 2x. Rearranging them, you will realize that okay, now it will start to look like 2x minus 1, okay, but with a negative in front. But of course, you're not gonna deal with like something like this, so we would recommend students to substitute something that looks like this. Okay, let e to the power of 2x minus 1 be maybe a, okay, something that looks quite simple. So the entire e2x minus 1, you just have to change them, okay, into a. 10, okay, a minus 11 is equal to 6. Okay, 6e to the power minus 2x minus 1 is still a, but with negative here, okay, with a negative 1. Okay, so this is where it becomes positive, the other one is negative. So now 10a minus 11 equal to 6 over a. How do you remove a? Just make sure you multiply a here, and then you multiply a here as well. So with this, you can basically cancel out the a. On the other side, you have to multiply a into the first and the second term. So 10a squared minus 11a is equal to 6, right? So yay, you are solving quadratic equations here. Okay, so that will be how do we get 6? 5, 2. Okay, then 6. So we can put at minus 3, negative 3, plus 2. That's going to give us 11, right? So 5 times 3. Yep, that's going to give us the answer. 5a plus 2 is equal to 0, or 2a minus 3 is equal to 0. So a is equal to minus 2 over 5. A is equal to 3 over 2. There we go. Are we done yet? Of course not. So we are just borrowing the identity. A is equal to e exponential 2x minus 1, right? So we have to switch it back. 2x minus 1 is equal to minus 2 over 5, or e 2x minus 1 is equal to 3 over 2. Then you just take ln of both sides. Ln minus 2 over 5. This answer you will have to reject it. Why? Because ln with a negative inside will be undefined, right? It will be math error, so just reject it. No need to waste time. Ln e2x minus 1, ln 3 over 2. So use power rule to move this in front, and then you know that ln e will give you 1, so technically you just have to ignore that one. But looking back at the instructions, I have to represent my answer in exact form, so I can't press my calculator to simplify ln 3 over 2. So 2x minus 1 is equal to ln 3 over 2. Move the 1, so there's going to be 1 ln 3 over 2, and 2, everything divide by 2, then x will be 1 over 2 plus ln 3 over 2 over 2. Okay, technically you can leave your answer like this. I'm sure this is like the simplest form that you can get, but of course you can also use the power rule to 1 over 2 ln 3 over 2. You can also move this up if you want so that it looks something like this. Okay, but technically it's up to you, but with by showing your answer here like this, it's good enough. Okay, so by doing all this you get 4 marks as well. So let's move on to the next questions. In these questions, all distances are in meters and time t is in seconds. A particle P is at a fixed point or at time t. So these kinematics questions will always give you the main equations that you have to either differentiate or integrate. So find the exact value of t for when the v is 0 for the first time after p leaves O. Okay, so when p leaves O, is t is equal to 0. Okay, that is when the v is also equal to 0, right? But of course, at a certain point, okay, we don't know the t. At that point, v is also equal to 0. So we have to find out the t. So v is equal to 3 sine 2t. So when your v is equal to 0, okay, sine 2t is equal to 0. So when this is basically all you have to remember when doing this, okay, doing trigonometry. So in order to solve sine something equal to 0, so 2t is always 0, 180, and 360. Okay, so just convert them to radian. So that's going to be pi and 2 pi. So time will be 0, pi over 2 and pi. But we are looking for the first time after p leaves 0. So other than t is equal to 0, we are going to look at the first time, okay, that it will stop. So the wanted answer is naturally t is equal to pi over 2, because we don't want 0, right? 0 is the first totally like where it started, so we want to know when the particle first stopped after leaving O. So it has to leave its initial positions, right? So time is equal to pi over 2. That is the exact answer. Now find an expressions for the displacement of p from O at time t. So you know the relationship between displacement, velocity, and accelerations, right? So to go down, it's always differentiations. Okay, differentiations. So when we go up, okay, from v to s, it's technically integrations. So integrate with respect to time. That's what we're doing right here. So v, given that v is equal to 3 sine 2t. So in order to go back to find s, we will need to integrate v with respect to time, dt. So therefore, we can start to look at do the thing. 3 sine, so sorry, let me just put it, 3 sine 2t dot dt. So integrate this, that will be 3. So sine, the integration of sine, okay, that will be minus cos. And then don't forget, with the chain rule of 2t, you're gonna divide by 2 plus c. That's gonna be your s, right? Therefore, s equal to minus 3 cos 2t over 2 plus c. So one information that we have is the particle, okay, is at O when time equal to 0. At O is where everything started, so the displacement will also be 0, right? So as when s equal to 0, your time is also equal to 0 seconds. So therefore 0 minus 3 over 2 cos 0 plus c, and we have our cos 0 will be just 1 for sure, then our c will be 3 over 2, right? S equal to minus 3 cos 2t over 2 plus 3 over 2. That is our final answer. Okay, final expressions that will get you 4 marks. Okay. Find the distance traveled by p, 0t. pi. So this question is actually fun. We want to find the distance traveled, and we have to look at the displacement here, right? The displacement is a cost curve, so you might have to sketch out a little bit. Okay, it's cos 3/2, so you should sketch it out, okay, without any issues. So this is basically time t and then s. Okay, we can observe how the particle move. So this is a negative cost curve. Negative cost curve should always it's going to be a cup shape, but it's upside down, right? So that's what you guys have learned. And the amplitude. Okay, so when I'm gonna set up, right, when t is equal to 0, so we want from 0, okay, pi over 2, and then it's pi. Okay, you just sketch out the curve. It's no big deal. Pi over 4, and then that is gonna be 3 pi over 2, 1.5. All right, sketch out. So when your time is equal to 0 times cos 0, so that's gonna be just 3 over 2, right? 1.5. So 1, 2. So it's 1.5. Hold on, let me set my calculator in radian mode. Minus 3 over 2 and cos 0 plus 3 over 2. So it's gonna be 0 here. It's gonna be 0. Okay, negative 3 over 2 plus 3 over 2 is gonna be 0. So negative 3 over 2 plus cos. We're just gonna plot my graph. A cos 0. Hold on. Did I just press it wrongly or something? So this is 0 minus 3 over 2. Negative 3 over 2 cos 2, 0. Okay. Oh my goodness, minus 3 over 2 cos 0 plus 3 over 2 is going to be 0. Minus 3 over 2 cos 2 pi over 4 plus 3 over 2. That's going to be 1.5, my bad. Okay, this here is going to be 1.5. So just mark it down on the graph. Okay, I'm just going to mark it 1.5 here. Okay, then 2 pi over 2, 3 over 2. So the highest point that they can go up to is 3. So I'm just gonna mark up 3. It doesn't have to be like very exact. So 3, and then it's gonna be going down here, and then it's going down here. So the movement of the particles, okay, as you can see, it's gonna go up, okay, to 3, and then come down back to the equilibrium line, right? So what's gonna happen here is your particles will go up, okay, the distance of 3, okay, after it went up, and then it will come down again with the distance of 3. So 3 meter plus 3 meter, so it will travel, is this in meter by the way? 0 meter, yes. Okay, 3 plus 3, therefore it's 6 meter in total. Okay, so by drawing out, you can basically see what is the pattern of how the particles travel from within the time interval of 0 to pi. Okay, let's come back to question 11. The tangent to these equations at the point where x equal to 3 meets the coordinate axis at point A and B, right? That's the first part of the questions. The point with coordinates A and A lies on the perpendicular bisector of AB. So our job is to find the coordinates of A. So let me just quickly roughly sketch it out so you can see what's going on here. So the graph is like this, and then we just assume that x equal to 3 is somewhere here. And then when it's a tangent is naturally the line where it touches the curve once. So technically we're looking for the point here and here, right? So first, step 1, okay, find the equation of tangent, okay, of the line of the light of this line. So how are we gonna do that? Okay, first find the derivative dy over dx. Okay, differentiate y with respect to x, so you're just gonna have to move the power in front. So 3x minus 1, 1 over 3 minus 1, and don't forget about the chain rule, 3x minus 1. So the chain rule is gonna need us to multiply by 3 on the inside, right? Cancel out the 3, So 3x minus 1, negative 2 over 3. So since we are looking at the point where x equal to 3, so sub x equal to 3 on the inside. Therefore, dy over dx is gonna be 3. Then you'll end up with 9 minus 8. 9 minus 1 is gonna be 8. So 1 over 4. Okay, so y is equal to 1 over 4x plus c. Remember, since it's a straight line, so we'll also be following the mx plus c rules. Okay, so y is equal to 1 over 4x plus c. And how to find c? So in order to find c, you have to know the coordinates. Okay, here. So here you know that it's 3, x equal to 3. How about the y? So in order to find the y, you just have to put, okay, using y is equal to 3x minus 1 over 3. So just substitute x is equal to 3 in order to find the y coordinates, right? 3 minus 1, 1 over 3. So that's going to be 8 to the power of cube, 1 over 3. So cube root of 8 is going to be 2. So 3, 2 is the coordinate that you need to find your c. Okay, to find c, use 3, 2. So 2, 1 over 4, 3 plus c. Therefore, c will be 2 minus by 3 over 4. The c will be 5 over 4. Okay, y is equal to 1 over 4x plus 5 over 4 will be your equations of tangent. And now we'll be looking into the next part where we have to find point A and B, right? So how? Point A and B technically crosses the coordinate axis. So to find A and B, okay, you have to assume when x is equal to 0 and when y is equal to 0. So when x is equal to 0, because this is where it cuts the y-axis, so y will be 5 over 4. So 0, 5 over 4 is reasonable. I call it at point A. When y is equal to 0, okay, so there will be 1 over 4x plus 5 over 4 is equal to 0. And technically everything is 4, so just multiply both sides by 4 to remove the fractions. You end up with x plus 5 equals 0. So x equal to minus 4, minus 5. Right? Negative 5, 0. So that's going to be B. Point A and B, we have it. So use point A and B to find perpendicular bisector. Use A and B to find the perpendicular bisector. So the gradient of AB will be 0 minus 5 over 4 minus 5 minus 0. So just punch your calculator real quick. Okay, divide by. So that's going to be 1 over 4, right? So gradient perpendicular to AB is going to be negative 4. Okay, don't forget the rules where m1 times m2 is going to be negative 1. So that's a rule of perpendicular gradients. Okay, so how about the midpoint? In order to find perpendicular bisector, you also need the midpoint. Okay, midpoint AB is gonna be what is that? 0 minus 5 over 2, 5 over 4 plus 0 over 2, right? So that's negative 5 over 2. So 5 over 2 divided by 2, that's gonna be 5 over 8. Find it. Y is equal to minus 4x plus c. Oh, we can continue to work, but never mind. To find c, use minus 5 over 2, 5 over 8, go down, 5 over 8, go work on it. So minus 4 multiplied by negative 5 over 2, that's going to be positive 10. So therefore c will be, okay, I think we might have the answer real quick. Minus 4x minus 75 over 8. So given that, okay, I'm gonna use a different color this time, since the coordinates is a and a. Okay, since it's point A and A, so x is a, y is also a. So just substitute, replace x and y in the equations. Then move this one, that would be 5a is equal to 75 over 8, right? A will be 75, 40. And then make sure you simplify them into minus 15 over 8. Or you can write it as minus 1.875. So last one. It is given that y is equal to ln 3x divided by x squared for x is greater than 0. Find dy dx. Give your answer in this form where a and b are integers, so you're required to simplify them at the end of the day. So this one is you can represent it as a function u and this one as v, and you'll know that you're ready to do quotient rule here. Okay, so just explicitly stating that the formula for quotient rule will be v u prime minus u v prime over v squared. Okay, so in this case our u is ln 3x, then u prime will be 1 over 3x with the chain rule multiplied by 3, so you're gonna be 1 over x, right? V will be x squared with the v prime as 2x. Now we are ready. So x squared 1 over x minus ln 3x and then multiply by 2x over the entire x squared square. So you end up with x minus 2x ln 3x and then x to the power of 4. Right, since you still can simplify further, so take out the common factor x, then that will leave you with x 1 minus 2 ln 3x over x to the power of 4. Then cancel out. What's the cancel out? dy over dx will be 1 minus 2 ln 3x over x to the power of 3. There you go. Okay, so where a and b are integers, we can double check our answers. So this will be our a, the negative 2 will be our b, and then make sure that it's ln 3x, and then make sure that the bottom is also x to the power of 3. So for part b, hence find ln 3x over x cubed. Okay, in order to find this integral, you may need the answer from the previous sections. So dy over dx is equal to 1 minus 2 ln 3x over x cubed, right? So how do you do this? It's easy. Just integrate this. Just put an integral symbol and then with respect to dx. Okay, with respect to x. Integrate y with respect to x. So dy over dx, you can always integrate it, so it will become y, right? Then that is equal to, okay, so to integrate this, it's better if you guys can just separate this, okay, into 3x over x squared dot dx. Okay, and we have to rearrange a few things here, so let me just rearrange them nicely. 1 over x cubed, let me rewrite this, yeah, 3x over x cubed dot dx is equal to y, and then I can separate them so that it looks like this, 2 ln 3x over x cubed dot dx is equal to y, and then you can move the entire 1 over x to the other side, so it will look like 2 ln 3x over x cubed dot dx is equal to y minus 1 over x cubed dot dx. Okay, are we done? Of course no. Okay, so there's a 2 here and there's a negative here, so what are we gonna do? Alright, we're just gonna move multiply. Okay, let me just close the bracket up. Okay, because I want to minus the negative 2 so badly, so I will just multiply by negative 1 over 2 to remove the negative sign and to remove the 2. But don't forget, whatever you do on the left, you also should also do it on the right. Okay, negative 1 over 2, put it in. So you end up with ln 3x over x cubed dot dx is equal to y, that should be negative y over 2 plus, okay, 1 over 2 x cubed dot dx. Okay, 1 over 2. Now, are we done? Of course not, not yet. but we are close, right? Let me just put it here. Okay, so this is just y, so you just basically put in whatever you have initially, but it's negative 1 over 2 multiplied by the y, that is ln 3x over x squared, and then plus 1 over 2, the integral of x 1 over x cubed. So 1 over x cubed is technically easy to integrate. Hold on, do I have enough space? Let me sort it out nicely. Okay, let me sort it out nicely. So I'll just move here. X to the power minus 3 dot dx. So I'm gonna show it to you how to do this. Minus ln 3x over 2x squared, and then plus 1 over 2, open up the bracket, minus 2, negative 2, plus c. Okay, since there is no limit there, so you have to add a constant c at the end. So there will be minus x to the power of minus 2, 4 plus c. Okay. So you'll end up with something like this as your final answer. Okay, so I hope you guys learned something from this video, find this video productive, and I'll stay tuned for more. I'll upload more videos in the future. Please take care.